Hello students, how are you people? So today, according to people's doubt, we'll be solving their doubts. Okay. Last time I've given you one question based on the previous topics, and many of you have done that question. And still there are many that who didn't solve the questions or who didn't get the answer. So today we'll be solving that question. Okay. So the question which I'm having in my book, which I've given you, it says that, once again I want to repeat that question. It says that a man walks on a straight road from his home to market 2.5 kilometer away with a speed of 5 kilometer per hour, full stop. Finding the market closed, he instantly turns and walks back with speed of 7.5 kilometer per hour. What is the magnitude of average velocity and average speed of man over the time interval of 30 minutes? First is this. Second question was 0 to 50 minutes. And third is what? 0 to 40 minutes. So in this time interval, in this required time interval, we need to calculate what? Average speed and average velocity. You might have written, everyone might have written the question, because last time I have given you people to write the question. So I am just here to solve the question now. So let's see about its solution. So in solution we are having what? We are having the distance 2.5 km. That is distance of the market. And what else we are having? The speed in which he goes. Why I am writing this as V1? Why I am writing in terms of velocity? Because it is a straight line which he follows. Okay, in question it has been written the road is straight. So the speed will be the velocity. Velocity how much? 5 kilometer per hour. While he goes, that velocity I am talking about. And in the returning from the market, what is his velocity? The distance is still the same. He is again following the same path. But in this case, the velocity is how much? Velocity is 7.5 kilometer per hour. So what is the magnitude of average velocity and average speed of man over the interval of 0 to 30 minutes, 0 to 50 minutes and 0 to 40 minutes? So let's try to solve the part 1. That is from 0 to 30 minutes we need to do. Okay, 0 to 30 minutes. So in between 0 to 30 minutes, before going to that, before going to calculate the average velocity and average speed in between this time interval in 0 to 30 minutes, and not knowing that how much distance our man has traveled. Okay, so before knowing that all those things, let us calculate what? Let us calculate the time which a person is taking in going from his home to the market. So we are having the displacement and we are having the velocity. So time T1 corresponding to these two values when he goes to the market. Okay, this is the time. Time is equals to what? Displacement upon velocity. So displacement I am having, V1 I am having. So displacement will be calculated in terms of 2.5 kilometers, and this will be what? 5 kilometers per hour. So now time what you will be getting? You will be getting time in hours. Okay, you will be getting time in hours, and it comes out to be how much? It comes out to be 30.5 hours. And when you convert this 0.5 hours, that will be equal to 1 by 2. It will come out to be how much? It comes out to be 30 minutes. Okay, 30 minutes. Now what we need to do? This time we have calculated while a person reach to his market, to the market. Okay, but at the same time he is having some velocity also while he come back to his house. So that velocity is equals to this much, and corresponding distance is what? Same. Okay, let me admit. So we'll be calculating the Okay, so time to come back home. Okay, that will be equal to what? I'm denoting it by T2, and this T2 is equals to same distance upon V2 velocity, and this will come out to be how much? S is how much? 2.5, and velocity is how much? 7.5 kilometer per hour. This is kilometer. So again the value will be coming in R. Okay, again the value will be coming in R, and it comes out to be 1 by 3 R. And when this R is multiplied with 60 to convert it into minutes, then how much it will be? This will be multiplied with 60, and this comes out to be how much?
20 minutes.
Okay. Now we are having the idea of time, that how much a body is taking to travel when he goes to a market, and how much the time a man is taking when he come back from his work from the market, when he found that the market is closed. Okay. Now, what is our first question which we have been asked? The first question says that in between 0 to 30 minutes, how much will be the average velocity and what? Average speed. Okay. So what will be the magnitude of average velocity in this case? In between 0 to 30 minutes. 0 to 30 minutes is the same time, okay, which a person is taking to go to the market. Okay, so what will be the speed which comes out to be in this case when he goes to the market will be same as that what we have been asked to do in between 0 to 30 minutes. Okay, so if someone asks us to calculate the average speed, so magnitude of average speed will be what? That is equals to speed is equals to displacement upon time. So displacement is how much? 2.5 kilometer. Time is how much? Time is how much? Time is 0.5 hours. That is equals to 30 minutes. This is what we have been asked to do. Okay. So instead of writing 30 minutes, I am writing like 0.5 hours. Okay. And what the value from here we get? When you divide these two, then the value comes out to be 5 kilometer per hour. Similarly, if we have been asked to calculate the average velocity, then what will be the velocity? Average velocity in that case, average velocity will be what? Average velocity is equal to displacement upon time. So displacement is how much? Whatever will be the distance, that will be the displacement, because the line is what? Straight. Path is straight, which he is taking. Okay. So this will be displacement upon time. Time I have been asked to calculate for 30 minutes. Okay. So 30 minutes is equals to 0.5 hour again. It comes out to be 5 kilometer per hour. So this is the value of average speed and average velocity for the first case. Okay. Now let's calculate the second part. And in second part we have to calculate the average velocity and average speed in between the time interval 0 to 50 minutes. Okay. So go back to the things which we have discussed recently. In that we have seen that how much a man is taking time to go to the market. He is taking 30 minutes. That's what we have calculated. And again to come back to his home, he is taking 20 minutes of time. Okay, that we have denoted by T1 and T2. So we are already having T1 is equals to 30 minutes and T2 is equals to how much? T2 is equals to 20 minutes. And this is equals to 0.5 hours. Okay. And this will be equal to how much hour? 20 divided by 60. So it will be 1 by 3 hour. This is what we are having. So if you see the question which you have been asked, that says that for 0 to 50 minutes, if you then T1 and T2 comes out to be how much? 30 plus 20 comes out to
50.
be 50 minutes. And this by this time, by the end of this time, by the end of time T2, he has again reached back to his home. That means if he is doing the journey like this in a straight manner from his home to the market, then after going back to the market, he has again come back to his home. So what is the value of net displacement? What is the value of net displacement? Anyone? Hurry up fast.
Sir, zero, sir.
Zero.
Zero.
Because now after this much interval of time, he's again back to his home. Okay. So displacement we are having 0. So obviously corresponding to that, the average velocity will be how much? Average velocity will be how much?
0.
Time. 0 upon time. Time is how much? 50 minutes. Okay. 50 divided by 60. We change into hours. Whatever there will be in the denominator, it will always be what? 0, because in numerator it is 0. 0 kilometer per hour. Okay. Now, what will be the average speed? How much distance he is covering? Average speed is equal to distance upon time. How much distance he is covering in this time interval? 30 minutes from here to here, 20 minutes from here to here. Distance is how much?
2.5 kilometers.
5 kilometers. So how much net distance he has covered during that time journey?
5
Five.
kilometers.
5, because 2.5 while going, 2.5 will come in. Okay, so it will be equal to what? 5 upon time. How much will be the time? 50 minutes. In between 0 to 50 minutes. So 50 minutes will be converted into hour. So when it will be converted into hour, then this 50 will be divided by 60. Okay, are you getting me? This 6 will go up. This will come down to be 6 kilometer. So this is the value of average speed. Okay, is it okay?
Yes, sir. Yes, sir.
So now, which is a little bit technical here, that is the third part. From 0 to 40 minutes we need to calculate. Okay, so this is the required time which our body is taking, or the man is taking to go to the market, and again he is reaching back in next 20 minutes. That means he is taking entirely 50 minutes of time to reach back to his home. But if you see this 40, 0 to 40 time interval, then this 40 may be lying in between 30 and 50. Okay, so if you compare this 30 and 40, then this 40 minutes is greater than this 30 minutes by 10 minutes. Okay, there is an increment of 10 as compared to this 30 if you are taking this 40. Okay, at the same time, if you compare this 40 with this 50, then there will be a decrement of 10 minutes again. So as a whole, that what we can see, that this 40 lies in just between what? 30 and 50. Okay, this 40 is lying just in between the 30 and 50. That means when our body is returning back from market to home, then at the end of 40 minutes, our body has just reached or completed the distance of half of this value. Okay, now we need to cover 2.5 kilometer distance. So according to this hypothesis, since it lies in the mid of this 30 and 50, 30 is the time to reach to the market, 50 is the time that he has reached to his home after covering his journey from the market. So 40 is in the mid. So that finally we can conclude here the final position, that is the F, will be in the mid of this displacement 2.5. So what will be the displacement now in this case? Displacement will be how much? 2.5 2.5 upon 2. That comes out to be how much? 1.25. If this is the net displacement, this will be the net displacement. That what we have calculated. That he is in the mid of his path, and this will be also what? S, that is equals to 1.25. And now what we need to calculate? We need to calculate what? Average speed. So we will be applying the formula of average velocity first. Average velocity will be how much? Velocity is equals to displacement upon time. So what is the displacement from his home? Final displacement is how much? 1.25. Okay? Are you people getting me? What I am saying?
Yes, sir.
So 1.25.
Yes, sir.
The time. Time is how much? 40. So T3 is how much? 40 minutes. So this minute needs to be converted into R. So this will come out to be 2.3 R. Okay. So just putting this 2.3 here now. 2.3 here now. So this will be in R. This will be in kilometer. So how much the value may be coming? How much the value will come from here after calculating?
So 1.87 something.
1.87 kilometer per hour. So this will be the average velocity. Okay. So now what will be the average speed? What will be the average speed? Average speed will be what? Total distance upon time. Now when he reach this final point M, which is in the mid, so he would have covered this distance initially, and then he is covering this distance MF, which is half of this 2.5. So this 2.5 plus half of this 2.5 will be the total distance. Okay, will be the total distance. I am not talking about displacement. So total distance will be how much? 2.5 plus 1.25 upon time is how much? 40 minutes. 40 minutes is how much? 2 by 3. So how much the value you people may be getting?
5.62.
5.62 kilometer per hour. This is the required value of the numerical. Okay. So I hope that everything is clear to you people.
Yes, sir.
Okay, thank you. So now we'll be discussing about the last two characteristics that we have discussed last time for time displacement graph. Okay. So last time we have discussed two properties, and now there is third property. Or there is third characteristic one can say. Okay, and that says that if the slope of the graph is negative in which in time displacement graph. Okay, in VT, in time displacement graph, then it means that our body is coming back to its initial position. It means that our body is returning. Okay, is returning. This is the third characteristic that we may observe while we plot such type of the graph in which slope is what? Slope is negative. Negative means what? Let us see about this graph. Okay. This is the time parameter and this is the displacement parameter. Let us see. Okay. So name the displacement as 0. Name this as 2, 4, 6 like this. And from this 6, I am getting or 2, 4, 6. Okay, let this be time. So you can see here now the angle which I am getting is greater than 90 degrees. The slope seems to be inclined like this in earlier case, but now I am getting somewhat like this. That is theta is greater than what? 90 degrees. Okay. So now what we can say? What we can conclude from here? That what will be the velocity in this case? Because velocity is what? Slope that we have discussed in the last line. So velocity is what? Slope, that is equals to what? Perpendicular upon base. Okay, that is equals to perpendicular upon base. Perpendicular is what? What is the final displacement at which the body has reached? S2 minus S1 we were doing like this now, upon T2 minus T1. This was the formula which we were using. So what is the final point of displacement of our body? Since after reaching this point, the body has reached this point. So what is the final point? What is the final displacement at t is equals to 6 seconds? What is displacement at this point? Anyone? 0. Nah? The displacement is 0. You can see that this axis coincides with the 0 of the displacement parameter. So 0 minus S1, initially the body was at 6. Okay, according to my graph, the body is at 6 meters. So 0 minus 6 upon T2 minus T1. Okay, what is the final time? Final time is t is equals to 6 seconds. A body has started its journey from t is equals to 0 seconds, because this is 0 parameter for time. Initial state of the body is this, final state of the body is this. So initially the body was at t is equals to 0. Finally the body has reached 6 seconds. So what we can write? T2 minus T1, that means 6 minus 0. So here the body, the slope comes out to be minus 6 upon 6. That is equals to minus 1. That is slope is negative according to this. Okay? Negative. Is this clear?
Yes, sir.
So another point is, if we are having this type of graph, that is the displacement time graph, and in this graph, if I am getting the parameters like this, okay, that means at different time intervals, I am getting different graphs. Okay, so one can say that the slope is continuously changing. Okay. For example, for this time interval, for time t1, the slope is something else. For this time, when it reaches the time t2 from 0 to 2, or from t1 to t2, the time slope is something else. And here the slope is flat, and again the slope is negative. So this is the case when the body is changing its velocity. Okay, when the slope is continuously changing, that means here is what? The change in what? In velocity at different rates. So this case may also be observed to you in the books. Is it clear?
Yes, sir.